Okay, so now we're going to take a unit of measurement that has a numerator and a denominator in it, and we are going to change the units in both the numerator and the denominator. So we're going to take 100 kilometers per hour, and what we want to do is convert it into some equivalent number of meters per second. And again, as with the previous conversion ratio problems, it's all going to be about using the conversion that gets you from what you have to what you want. So what we need to do is, in our numerator, get from kilometers to meters, which we can do using the fact that we know 1 kilometer is equal to 1,000 meters. And in our denominator, what we want to do is convert from hours to seconds, which we will do using the fact that we know 1 hour is equal to 3,600 seconds. Now, what makes this problem a little different than the other ones is that we are not just changing units of measurement in one part of the fraction. So we are changing units of measurement in both the numerator and in the denominator, but it's still all about canceling what you have to end up with what you want. So I'm going to write the 100 kilometers over 1 hour, just to emphasize the fraction form of these unit rates. Remember, a unit rate is a rate where the denominator has a coefficient of 1. So when we say 100 kilometers per hour, we mean 100 kilometers in 1 hour. So what I'm going to do first is remove the kilometers and end up with meters. So I've got kilometers in my numerator in my first fraction, which means I want kilometers in the denominator so that they'll cancel. And I want to be left with meters in the numerator. So I know that there are 1,000 meters for every 1 kilometer. That allows the kilometers to cancel. And if I stopped now, I would be left in meters per hour, which is not what I want. I want meters per second. So now I need to change the units of measurement of hours in my denominator to seconds, which means that if I'm going to cancel with the hours, I need to put the hours in the numerator of my last fraction and put seconds in the denominator, because that is the form of my answer. Meters up top, seconds down below. So 1 hour is 3,600 seconds. That's my conversion ratio, which allows the hours to cancel. Remember, this is just one long product of fractions. So when you have matching units between a numerator in one fraction and a denominator in the other fraction, those units of measurement will cancel. So now I have, in my numerator, 100 times 1,000 times 1, but we don't need to put the times 1 in there. And I have in my denominator 1 times 1 times 3,600, which is just 3,600. And the units of measurement that are left are meters in the numerator and seconds in the denominator. So that's meters per second. And when you do the math, so 100 times 1,000, and then divided by 3,600, you end up with 27.7, which repeats, meters per second, which you can round just to 27.8. meters per second. So again, changing units of measurement using the cancel out technique just means setting up conversion ratios so that what you want to cancel ends up in the numerator of one fraction and the denominator of another fraction. Then those units will cancel out, and whatever is left over should be the units of measurement that you want.